Show that the locus of a point which maintains a constant sum of distance of 2a from two fixed points with coordinates ae, 0 and negative ae, 0 is described by this particular equation. Let us begin. So we have here, let's say, a point A. A has the coordinates negative a times e, 0. Then we have another point B. B has the coordinates positive ae, 0. There is a point P. We're going to name its coordinates as h, k. Now this particular point P is moving. Now the condition it's given here that the sum of the distances. That means if we join PA and we join PP, then the sum of the distance PA plus BP, that's always fixed and it has a constant distance of 2a. Fine. So using this particular criterion, what we have to do is show that the equation of the locus is given by this form. Okay, let's begin. So PA, all we have to do is take the square root. So this is what we do for finding out the length between 2 points using the distance formula. So since we're concerned with PA, we only need the endpoints P and A. So underneath the square root, first what we'll do, we'll take the difference of the x coordinate of both the two endpoints. So we have h minus negative a, so we have h plus a whole square. Added to, then we have the difference of the y coordinate, so that's k minus 0, square it. And this will be added to square root of PB to the length of PB. So we'll again use the distance formula to find out the length PB. So first we'll take the difference of the x coordinate. So we have h minus ae whole squared added to the difference of the y coordinate. So that's k, square it, and this will be equals to 2 times a. Okay, let's further simplify. We'll keep one of the square root on the left hand side. So we'll keep h plus ae whole squared plus k squared on the left hand side, and then we're going to transpose the second term to the right hand side. So we get 2a minus square root of h minus ae whole squared plus k squared. Now we're going to square both sides. Squaring both sides, that's going to give us h plus ae whole squared added to k squared, and this will be equals to, so we have square of the two terms on the right hand side, so we can expand it. We get 4a squared minus 2 times 2a, that gives us 4a, and we have multiplied to it is square root of h minus ae whole squared plus k squared. Then added to square of the second term, so that's h minus ae whole squared plus k squared. Fine. Now what we can do, we can immediately cancel out k squared from both sides. Now we're going to expand h plus ae whole squared on the left hand side. We get h squared plus 2 times aeh plus a squared e squared. This will be equals to 4a squared minus 4a multiplied to square root of h minus ae whole squared plus k squared, and this will be added to h minus ae whole squared. Let's square it as well. So we have h squared minus 2aeh plus a squared e squared. Now also we can easily cancel out h squared from both sides. We can also cancel out a squared e squared from both sides. Now what we'll do, we're going to rewrite all the terms. Now what we'll do, we'll take this to negative 2aeh, transpose it to the left hand side and combine with this particular 2ah, and this is going to give us 4aeh. Fine. Then we are left with this constant term 4a squared. We'll take it to the left hand side. We have negative 4a whole squared, a squared. That will be equals to negative 4a times square root of h minus ae whole squared plus k squared. Now let's get rid of all the 4 from each of the terms we have, and we can also factor out 1a. Now let's do one thing. Let's take 4a as the common factor. So here we have e times h minus a, and that will be equals to 4a. So we have 4a multiplied to negative times square root of h minus ae whole squared plus k squared. Fine. We can factor out 4a from both sides, and we are now left with eh minus a, that will be equals to negative times square root of h minus ae whole squared plus k squared. Let's square both sides. Squaring both sides, we get h minus a whole squared. This will be equals to h minus ae whole squared plus k squared. Now let's expand this. We get e squared h squared minus 2aeh plus a squared. This will be equal to h squared plus a squared e squared minus 2aeh plus k squared. So we can cancel out negative 2aeh from both sides, and then we have now so we're going to flip it. So we have h squared plus k squared plus a squared e squared, and this will be equals to e squared h squared plus a squared. Let's transpose this a squared e squared to the right hand side. So we get h squared plus k squared. That will be equals to e squared h squared plus a squared minus a squared times e squared. Now we have a relation that's given to us. We are given that b squared equals to a squared times 1 minus e squared. So we're going to use this particular fact. Let's note it down, where b squared equals to a squared times 1 minus e squared. That's provided to us. Now what we'll do, we're going to combine the second and the third term. We have, let's do one thing. We have h squared. We're going to transpose this e squared h squared to the left hand side. So we have negative e squared h squared plus k squared. And here we're going to take a squared as the common factor. So this will get multiplied to 1 minus e squared. Fine. Now here if we take h squared as the common factor, so we have 1 minus e squared added to k squared, and this will be equals to a squared times 1 minus e squared. So we can replace a squared times 1 minus e squared with b squared. So this will be simply b squared. And here we have 1 minus e squared. So clearly 1 minus e squared, that can be also expressed as b squared over a squared. So we have h squared times b squared divided by a squared plus k squared equals to b squared. Fine. Let's do one final touch here. We're going to divide each terms with b squared. So we get h squared over a squared plus k squared over b squared, and this will be simply equals to 1. Now what we'll do, we're going to replace the value of h with x and the value of k with y, and that's going to give us the locus of the point. So we now get x squared over a squared plus y squared over b squared equals to 1. So this is the locus of the point P. Now clearly there is let me quickly show what kind of a path the locus of that particular point P is going to do. So we say that we have two fixed points. One is negative ae comma 0 and the other point is positive ae comma 0. Now our point P, which we have chosen in such a way, that means this particular distance added to the distance between these two, so PA and PB, that sum of the distance is always a constant. So no matter where we consider P, if we consider P to be at this point, then this sum of the distance of PA and PB, that's always going to be constant. And if we trace that particular point P, then the locus of that particular point P is going to trace an ellipse. So actually this is the equation of an ellipse.